Okay, so in this class, we are going to talk about the next chapter, that is angles. Okay, now this is what happens exactly every time when I start off with a lecture. Okay, all right. So angles are simple. Some students find them a bit technical because they don't know all the properties, and then they start doing the questions without knowing all the properties. So let's just talk about all the properties, all the theorems and angles, and then we will talk about past paper questions. Okay. It's angles. All right. Okay. First of all, let's talk about vertically opposite angles. Okay, so imagine you have two lines. This is line 1, this is line 2. They are intersecting each other. So this pink angle is vertically opposite to this pink angle, and this blue angle is vertically opposite to this blue angle. And the property says that vertically opposite angles are same. So this means that if this angle is x degrees, if this is y degrees, x degrees would be equal to y degrees, right? Similarly, if this is equal to z degrees and if this is equal to t degrees, so this would imply that z degrees is equal to t degrees. So just know, whenever you have two lines, the two lines are intersecting each other, vertically opposite angles are going to be same. Okay, and what exactly vertically opposite angles look like? So it's this blue angle, that is x, and it's this y degrees, and they are same, right? So this is rule number 1. I won't be writing down all the names and everything. This was the first one, that is why I've mentioned it this way. Okay, for the second one, so if you have a straight line like this, and then let's say you have one line, and then you have another line, and then let's say you have third line, let's say you have another line, you can have infinite many lines, that is completely fine. What is the property exactly? So the property says that this angle, let's say this angle is A, this is B, this is C, this is D, and this is E. Does anyone know about this property? What is the sum of A, B, C, D, E?
180. 180
Ma'am,
degrees.
360.
180. 180. Very good. Very good. Okay.
Okay.
360 is when it's in a circle. Okay. That's
Yes,
fine.
ma'am.
No, it's fine. It's fine. So angles on straight line, or sum of angles on a straight line, is going to be 180 degrees. All right. So we know that A degrees plus B degrees plus C plus D plus E is equal to 180 degrees. Okay. All right. Another one. Now your answer would be correct. So imagine this time around, you have again this, then you have this, you have this. So now if I talk about this angle, this angle, this angle, this angle, this angle, this angle, their sum is going to be 360 degrees. So for now, we know that if you have a straight line, sum of angles on a straight line is going to be 180 degrees, and sum of angles in a circle is going to be 360 degrees. Okay. Then the fourth one is, so this time around, we have a triangle. It could be any triangle. It could be scalene, equilateral, any triangle. You guys know that we have, different types of triangles. This is the triangle. So imagine this is x degrees, this is y degrees, and this is z degrees. The property says that sum of interior angles in case of a triangle is equal to
180 degrees.
very good. It is 180 degrees. Excellent. Okay. Now, these were some basic properties. Let's talk about some more properties. Okay. Now imagine that, trust me, these properties are very important. Okay. Some of you would be thinking that these are very basic. We will talk about all the properties in this class, and then tomorrow when we will talk about past paper questions, you guys would find them easy if you have all these properties in your mind. Okay. So the next one is something of this type. So there's this triangle. Okay, this is a triangle basically, and this angle is A, this angle is B. Can anyone tell me what would this angle be? Just by using basic logics?
A plus B.
Very.
Ma'am, yes,
Yes.
ma'am. Yes,
Okay.
ma'am, A plus B.
Excellent. Okay. Now, why exactly is it A plus B? So we know that this angle right here is basically going to be 180 minus A plus B. Why? Because sum of angles in case of a triangle is 180 degrees, okay? And if I talk about sum of angles on a straight line, that is also 180 degrees. Are you guys getting this thing?
Yes, ma'am.
Right? So because of that, this blue angle is going to be A plus B degrees. And this is a property technically. So if some of you were not able to understand, it's fine. But I personally hate memorizing properties. I was never able to memorize such things. I always used to talk about logics, but it is a property. So let's think about it as a property directly. Okay. And then you guys would get to understand that even better in the future. Okay. Some more straight lines now. Sixth is basically, so we have two perpendicular lines. Now, what exactly two perpendicular lines look like? They look like this. And then we have a line that is cutting them. So this is basically called the transversal. Okay. Let's talk about corresponding angles now. Corresponding makes sense, right? It is self-explanatory. So this angle, this pink angle and this pink angle, they are corresponding, right? Corresponding angles are equal. Similarly, this blue angle and this blue angle, they are also equal. Okay. Then this yellow angle and this yellow angle, they are also equal. So the property says, let me just write down the property. It says that corresponding angles are equal. Now, which angles exactly are corresponding? Just know the meaning of corresponding and then you guys would be able to relate to it. Okay. So for instance, let me just make another sketch to explain this properly. You have two perpendicular lines, and then there's this transversal which is cutting the two lines this way. Think about corresponding. So if I have something over here, its corresponding angle would be this one. They are equal. Similarly, this yellow angle and this yellow angle, they are corresponding. So they would be equal. Then this angle and this angle, again, they are corresponding. So they would be equal. So you guys need to just know the meaning of corresponding. Think about corresponding angles, and then whatever angles are corresponding, they would be equal, right? Okay. All right, okay. Then the seventh property is, this would get better once we talk about questions, so just relax, okay? The seventh property is again about the stuff. So you have two straight lines, and these two straight lines are being cut by a transversal. Let's talk about all alternate angles now. So this angle and this angle, they are equal because they are alternate angles. Okay, so the property says that alternate angles are equal. Similarly, this angle and this angle, they are also alternate, so they would also be equal, right? This is how exactly alternate angles look like. Okay, next one. If anyone has any query during these, theorems, just stop me right there and ask me directly, okay? Acha, the next one is basically the ninth one, and it says, so this time around we have two perpendicular lines. The two perpendicular lines could be this way, they could be this way. The two perpendicular lines could be any way, okay? And again, you have a transversal. So it says that the sum of this angle and this angle is going to be, yes, it's going to be 180 degrees. Let me just write it down here. Okay. So basically, these two pink angles are interior angles, and you can think about them as supplementary angles. Supplementary angles are basically those that when you add them up, it gives you 180. So let's keep it simple. Okay. You have two perpendicular lines, they're being cut by a transversal. Just take out the interior angles. These are the two interior angles. Then we have this and this as two interior angles. Similarly, this is your transversal. So this is your interior angle and this is your interior angle. Similarly, this is your interior angle and this is your interior angle. And the rule says sum of interior angles is equal to 180 degrees. So when I write this, it basically means if this is A and if this is B, A plus B is 180 degrees. Similarly, if this is C and if this is D, C plus D is 180 degrees, right? So sum of interior angles is 180 degrees, or you can call them supplementary angles because this is what supplementary means, okay? So these are some basic properties that you guys would be familiar already, but the examiner would hardly ask question from these. He is interested in giving you questions from basically the circle property part. So that is more important and that is more complicated, right? So these were some basic properties. We will be using all of these now. Let's talk about the 10th one. Now this is important. Please pay attention, okay? From this property, we have basically started circle properties. Okay. Now imagine that you have a circle. It looks like an oval. Wait, like 1 second.
Ma'am, can you send these properties in the group as well?
Yes, definitely. I can certainly share these. Okay, don't worry.
Okay, ma'am. Thank you very much.
You're welcome. Okay. So it says the angle at the center is twice the angle inscribed at the circumference. Now, what exactly this English means, I'll tell you. So we have this center of the circle. Then we have this line. What is this line called? Can anyone tell me? Is it the diameter? Is it the radius?
It's a chord.
Very good. Okay. If there's a line that is connecting circle at 2 points of the circumference, that basically is a chord, and the largest chord is basically your diameter. So a chord that is passing through the center of circle is basically your diameter. Very good. So this is the first chord. Then we have another chord like this. Okay. 1 second. Let me talk about this one first. This is your chord. Then we have another chord, okay? Okay. The property says, now I'll read it, okay? The angle at the center, this angle at the center of the circle is twice the angle at the circumference. Okay. Now, what is happening? Now, every time we know these properties in the actual question, the scenario is not same, but still some of you would be saying that we will be using the first property of circle theorem. No, that's not true. Okay. You need to make sure that this angle, this blue angle is being made at the center, and this angle, this one is being made at the circumference. For example, let's say if there's another circle, and this time around, we have something of this type. This is the center, for instance. Now you guys can't say that this is 2x and this is x. That would not be true. Why would this not be true? Because the property says angle at the center is twice the angle at the circumference. Okay. So this has to be at the circumference. This is not at the circumference. That is why this is not true. Okay, so you need to be sure that whatever conditions we have in that very theorem, you need to have those in the question first. Only then you guys can relate to that theorem. Okay, let me write it down as well. So it says angle at the center is twice the angle at circumference. Okay, now this could be the question that you have a circle and this is your center. This is your first chord. This is your second chord. And this is the thing. And you have been told that this is, let's say, 200 degrees, and you have been asked to find this. Okay, now obviously it's not necessary that this kite shaped thing is being made like this. It could be like this as well. The only rule this property has, that the two angles should be at center and circumference. Center and circumference. Okay, so if that is 200, this is going to be 100, right? And let's say if this was your question, let's say, let me give you another question for this then. Let's say you were told that this angle right here is basically 70 degrees and you were asked to find this one. Can anyone tell me what would this x degrees be?
360 minus 2 times 70.
Very well done. Excellent. Very good. Yes, that's perfect. Okay. So this is how exactly we will be using these properties. Let me explain this again. So all of you just think about this question right here. Think about this the question. You have a circle. First angle is at circumference, second angle is at center, but just look at it. So here, this was the angle at circumference and this was the angle at center. This was not the angle at center, okay? But you have been asked other way around. So you have this angle at the circumference and you have been asked about this angle. So you don't know anything about this angle. What you can do is just use the property and say that angle at center is twice the angle at circumference. So this, you can find this angle, right? If the angle at circumference is 70 degrees, this would be 140 degrees. And then you will say that sum of angles in a circle is basically 360 degrees. So 140 minus 360 would give you, or 360 minus 140 would give you 220 degrees. Okay, so x
Ma'am,
is going to be 220. Yes.
ma'am, how would we find 140, like in the middle?
Yes, I'll tell you. So basically, this for this we have used this first property of circle theorem. Technically, this is the 10th property, but we have just started talking about circles. So this is the first property. And the first property says, if you have a circle, if you have two angles, one angle is at the center, like this is the center of circle, this is the center angle, it's 2x, and this angle is basically at the circumference. The rule says angle at the center is twice the angle at the circumference. In this question, we had this angle at the circumference and it was 70 degrees. Okay. Using the same property, I can see that this angle right here is being made at the center. So it would be twice the angle at circumference. So it would be double of 70. That would be 140, right? I got 140
Okay.
from there, and then using sum of angles in a circle is 360. Then I knew that x would be 360 minus 140.
Okay.
Yes. Were you guys able to understand this?
Yes, I was able to understand.
Okay, this would get better in some time. Don't worry. Okay, just relax. Let's talk about the second property that's just like the first one. Okay, and you guys would be able to do this. So this is basically the 11th property of the entire chapter. It says now you have a circle and you have this as the center. This is your diameter. And again, this is your chord 1. And this is your chord 2. My question from you guys is, can anyone tell me what would this angle be? Like those who know this already, please don't answer this. But those who have started understanding this, can you guys tell me what would be this pink angle just by thinking about it logically? Again, the same logic, angle at center and angle at circumference. It's same. You can find this angle.
90,
Very
90,
good.
ma'am.
Yes, well done. So we know that angle at center is twice the angle at circumference. This time around, our shape is not just like what we had in the first property, but that is irrelevant. Okay, that is irrelevant. What we know is we have two angles for this property at center and at circumference, and we can see that this angle at the center is 180 degrees. Why? Because it is a straight line. If this is 180 degrees, this angle is going to be 90
90.
degrees. Okay, very good. And for 90 degrees, we usually make square like this. Okay, so this is what exactly the property was. So just know that if you have a diameter type of a thing, then it would be 180 degrees and the angle at circumference would be 90 degrees. Okay. All right, let's talk about another property and then I'll try giving you a question using these three properties just so we get to practice the concept there and then. This is basically the 12th property of the chapter. Oh, and it says, one second. Okay. So again, we have a circle because we are talking about circles for now. This is not a circle. This is circle. Okay. And the property is 1 second. अच्छा, okay. Let me make two straight lines because this way this would not turn out to be correct. Yes, okay. All right, okay. So before talking about this property, let me explain one concept properly. This entire outer boundary of the circle is basically called the circumference, right? But if I talk about some specific part, if I talk about, let's say, this specific part, like some part of the circle, of the circumference, so you can think about it as the arc of the circle, right? Arc is just some part of the outer boundary of circle. That is it. So this is a circle, and this is basically some part of the circumference. So it is an arc. This is also an arc. This is also an arc, right? Some part of the outer circumference or outer parameter of the circle is basically an arc. Okay. Now the property says angles subtended by the same arc are equal. Okay. Now just look at this. This x degrees is starting from here. It's ending at this point and it is making this pink arc. Okay. It is making this pink arc. And again, if you look at this angle right here, this angle is starting from here, it's ending here, and it is making the same pink arc. So the property says angles subtended by the same arc are equal. Now this English basically means that if you come across something of this type, and if you guys are able to see that this line and this line, if these two lines are making the same arc as the two yellow lines, this would mean that both the angles are same. Okay. Similarly, this was for this shape. It could be any way, right? So for example, if you look at other way around, if you look at this part of the circle, let's say this is y degrees. Now this is starting from here, this is ending here, and this is making this pink arc. This is making this pink arc. And if I look at this angle right here, again it is starting off at this point and it is ending at this point. This means that it is also making the same pink arc. So this would also be y degree. So I would just help you with this. If you have a circle and if you see this non-symmetrical butterfly shape, just know that this property would be applied. Okay. So whenever you see a butterfly shape, just think about this third property and then try relating to it if the angles are making the same arc or not. If they're making the same arc, both the angles would be same. Any confusions with this?
No.
Okay. All right. Okay, perfect. So let me quickly take out one past paper question just so we are able to practice this. It would be a simple question, not very complicated, because we still have a few more properties and we'll talk about them tomorrow. Okay, perfect. So I got one question. I am going to just make a PDF quickly and I'll just share it.